This is another example of symbolizing a complex statement. In this statement, we're going to have more connectors. Remember, whenever we set out to symbolize a complex statement, we start out by identifying the simple statements. Here we have the complex statement: if Kermit is a frog, then he's either green or blue, and he's not blue. So let's see. Kermit is a frog is one of our simple statements. That one's pretty straightforward. What else do we have here? Well, we have he's either green or blue. So he's green or he's blue. And either isn't part of our simple statements. He's green or he's blue. And then we have, and he's not blue. That's that he's blue simple statement again. So the three simple statements we have here are kind of straightforward: Kermit is a frog. And then we have a very short statement: he's green. Let's make it clear in our simple statement that it's Kermit that is green. And he's blue. That's Kermit is blue. Notice this is part of the reason that we want our simple statements to be positive. In this sentence we have he's blue. We also have he's not blue. But those are instances of the same simple statement. Let's see, let's give these names. We could call this one P, this one Q, and this one R. There's nothing special about the order in which I'm naming these. You could name them R, Q, P, and as long as everything's labeled correctly, you would get the same symbolization, just with different letters in different places, and that's fine. Okay, so the simple statements were hard to find. The connectors are also complicated because we have three of them. We have an if-then, we have an or, and we have an and. Okay, what helps us here? One of the things that helps us is the commas. Notice we've got two commas here. This comma separates the if part from the then part. So there's something bridging that, saying that this part of the sentence is one whole thing. But there's nothing bridging this and. This part of the sentence is one whole thing. The punctuation, in particular the commas, help us to identify that that and is the main connector. This is often tricky in English when we have long, complicated statements like this, because English doesn't do very much to tell us when it's subordinating a clause as opposed to when it's making a clause parallel. So this is a place where, unfortunately, the best advice is be very careful and pay close attention to the punctuation. And also, as you practice these in the homework, you will get more comfortable with them. So our main connector is an and. We'll have something before the and something after the and. What do we have before the and? Before the and, we have the very long, if Kermit is a frog, then he's either green or blue. How do we know what the main connector here is? Well, one of the things that helps us is that this he's either green or blue is clearly a unit. Why? because the subject and verb only occur once. He is. And then green or blue is just tacked on to the end of that. Those are clearly dependent on each other. So that is clearly a unit, which means that Kermit is a frog is the other part. The main connector is the if-then. So we have the skeleton of an and. We'll put in a skeleton of an if-then in the part before the and. Okay, now we're still working on this first part. It's an if-then. The if part is Kermit is a frog, and that's just P. The then part is he's either green or blue. Referring back, he's green was Q, he's blue was R. This is just Q, this wedge shape for or, and then R. Okay, now our statement fills in as our first part. We want to put P in before the if-then. That doesn't need parentheses around it. Q or R after the if-then. That does need parentheses around it. And then close the first parentheses. And something we haven't figured out yet. Okay, what do we have after the main connector? The main connector was that and. After that we have and he's not blue. So after the main connector we have he's not blue. And that we would symbolize as not R. Remember, statement R was he is blue. Not R is he's not blue. So our statement then, we have P, then Q or R, and after the and, we just have not R. Okay, as you can see, we can get to have a lot of parentheses to keep track of in these really big, long, complicated statements. When do we need parentheses and when can we leave them out? The answer is, so in algebra, order of operations tells us when we can leave parentheses out. In logic, the order of operations is really simple. Not comes first, and everything else comes after. If you have anything else that's anything other than not, you need parentheses around it. So you need parentheses anytime you're connecting two statements. You don't need parentheses around a not, so we could write not R here, and we don't need to put that in parentheses. And then we don't need parentheses around the whole final statement. Other than that, anytime you have a connector, you need parentheses around it. No parentheses around not, no parentheses around the outside, parentheses the rest of the time.